Hello guys, we will explore how ByteDance made this model computer use agent that can use computer's web browser, terminal, and solve tasks on computer. And it's competitive with OpenAI, Anthropic's models, etc. And this is really good because they show step by step everything, how they build it, what they did, and the problems, the solutions, unlike these other companies, OpenAI, Anthropic. Somebody told me that I should explain more stuff with my own words as opposed to reading from the screen. So I read that feedback in the middle of recording this video. So first part of the video, I'm going to be reading more. The second part, I'm going to be explaining with my own words. And hopefully future videos, I'm going to try to explain with my own words more and more. This paper starts by identifying the central goal, creating an autonomous agent that can intelligently operate computers using graphical user interface, just like a human does. Think of it as an AI that can see the screen, understand a goal. For example, book a flight to New York, and then move the mouse, click buttons, and type text to complete the task. However, building such an agent is extremely difficult. The authors identify 4 major challenges. Data scarcity. It's hard to get enough high-quality training data, unlike text or code, which exists in vast quantities online. Detailed recordings of someone reasoning through a computer task, thought, action, result, are rare and expensive to create. Unstable reinforcement learning. RL is a powerful technique for teaching agents through trial and error, but it's notoriously unstable for complex, multi-step tasks. Rewards are often delayed. You only know if you succeeded at the very end, making it hard for agent to figure out which of its many actions were good or bad. Limitations of GUI-only operation. Many real-world tasks can't be done just by clicking and typing. A developer might need to run commands in a terminal or manage files in the file system. A pure GUI agent is limited. Environment instability. Training an AI agent requires running millions of simulations in virtual machines or browser sandboxes. These environments can be fragile, slow, and prone to crashes, which is major engineering bottleneck for large-scale training. UI TARS 2 is a system designed to tackle all 4 of these challenges. The UI TARS 2 methodology. How does it work? This is the core of the paper, where they explain their solution. First, the paper defines what the agent is and how it behaves. Concept: native agent perspective. This means the agent is a single end-to-end model. It takes in visual input, screenshots, and text instructions and directly outputs actions. There are no separate, hand-coded modules for perception, planning, etc. The entire process is learned from data. Concept: React paradigm. The agent operates in a loop, mimicking human problem solving. At each step, it forms a cycle of reasoning thought. It thinks about the current situation, what the goal is, and what to do next. Okay, I see the login page. I need to type the username in the username field. Action: it performs an action in the environment. Observation: it gets feedback from the environment, a new screenshot showing the result of the action. And then we have concept hybrid action space, GUI plus SDK. This directly addresses the GUI only limitation. The agent can perform 2 types of actions: GUI actions, click, type, scroll, and similar, and predefined SDK functions, a set of special tools that go beyond the GUI, such as running terminal commands or managing the file system. This makes the agent far more powerful. The environment where the agent lives. To address the environment instability challenge, they built a robust all-in-one testing platform. They have this all-in-one GUI sandbox that is unified environment that can provide many different things for the agent. It has a shared file system where agent can do things like download file from the browser, which is a GUI action. And then it can maybe use terminal to process that file, which is all in the same session. It also has cloud virtual machines to run entire operating systems like Windows, Ubuntu, at a very large scale for training, pre-training. And then a specialized sandbox for browsers that runs web browser very efficiently and quickly. And it has some options to speed up time simulation, something that's happening in the browser. To solve the data problem, they have this data flywheel. So instead of creating all data at once and then training on it, they actually let data improve, self-improve. A flywheel is a heavy wheel that once spinning keeps its momentum. So here wheel is the cycle of data self-improvement. In the beginning, they start to train with the initial initial model, and then use the new model to solve tasks. And then tasks that are easily or quickly solved. This is high quality data for supervised fine-tuning, and lower quality data where models struggled. They are not thrown away, they are just used for continued pre-training, but they are not like high quality for supervised fine-tuning at the end. And so you retrain the model and generate data again, and so on. So it's like a self-improving in this case. This is really nice in comparison to text models, because text models cannot actually generate, text models don't have some environment against which to check if their text is good. Maybe for just mathematics or code, but here in this GUI, the model actually can check if it's solving the tasks properly on the computer, if the task is solved. So this can generate data self-recursively. Better model generates better data, and so on. And then for the highest quality data, they have a human helping it, but the human is not gonna check the correctness. Actually, the human is gonna tell the model and suggest what to do. If human sees model making a mistake, it can immediately stop it and suggest it to do something else. So human is helping the model while it's training. The reward design. There are two types of tasks. Verifiable tasks where you can check automatically if the result is correct, and these other tasks where you cannot check automatically. So for the other tasks, they use another LLM like GPT-4 or 4o or Quen or whatever the better LLM to judge the correctness of the task. Wait, it looks like they use GPT-4 also for these verifiable tasks. So LLM for the verifiable tasks. And for non-verifiable tasks, open-ended tasks, that don't have a single correct solution, for example, they create an outcome reward model. This is a model trained specifically to look at the trajectory and predict a success score. In this case, they use UI TARS to itself as the ORM, so the model that they are training. There is another issue as well. So traditionally, you have a batch of tasks. So you have multiple tasks, all independent tasks, and you wait for all of them to finish, and then to reward the model, to update the model. Well, if one task is very long, then all of the other tasks just need to, so the GPU needs to wait, the model needs to wait until the longest one finishes. So it's a wasted time, wasted compute resources. Their system is asynchronous. It uses a streaming approach where training updates can begin as soon as a minimum number of tasks are complete, while the longer tasks continue running in the background. They use proximal policy optimization by OpenAI, but they have some more tricks added to it to make it more stable and effective for long, complex tasks. And instead of training a single model from scratch to know everything, GUI games coding, they actually train specialist models, one just for GUI, for web, maybe for games, for coding. In the end, they just merge all of those models by averaging their weights. And I have a recent video on how to train LLMs without pre-training, so just by averaging weights, or how to do this model merging better. This works surprisingly well because models trained from the same starting point tend to learn in compatible ways. It's a cheap and efficient way to combine diverse skills without extensive joint training. So instead of needing to have a separate data set that combines, for example, coding and GUI, we just train separate GUI, separate coding, and then merge them, and now it's gonna be good at tasks that require both of them, both coding and GUI. Their model actually outperforms even OpenAI and Anthropic on some of the benchmarks. They also found out that if you give it more time to solve problems, it solves problems better. So this is inference time scaling. So which means the model learned how to solve problems, didn't just maybe memorize solutions, but it learned how to solve problems. They also trained, when they teach a specialist model, on like SDK using commands, and then they merge with the GUI model that just knows GUI. Actually, now the new model is even better at the GUI. So it applies what it learned from SDK to GUI, and now it performs generally better. Check out other videos on my channel. Also, people say that my titles aren't accurately representing 100% what the video shows, so I'll look to improve that. It's actually not so easy to do. To summarize entire video in a single title, it's a bit difficult, but maybe I'll use AI to help me or something.